Okay, so thank you all for coming. Thank you very much. Bill, who's in the audience today, he, our MC for the conference, he told me that any good presentation, any good session needs to start with the true story. I decided, to start one today as well. So here it goes. ChatGPT 3.5 and ChatGPT 4 walking down the street. And ChatGPT 3.5 stumbles and falls, and then ChatGPT 4 obviously laughs and says, "Hey, looks like you have a latency problem." Yeah, I told ChatGPT 4 that it wasn't really funny, but she told me to tell it anyway, so it's okay. All jokes aside, guys, so today hopefully will be an exciting session. And it looks like not just this session, but I said today through a few sessions, it looked like not just this session, but the whole conference is in one way or another is dedicated to the effect of ChatGPT, AI, large language models will have on the data center industry. So I hope that this session will add to that knowledge. And I truly believe that just like the revolution of the 1990s and 2000s of the internet, that AI is the next revolution. It is here to stay. It's not a fad. It will change the way we live. It will change the way we work. And I personally think that we are super lucky to live in this time. And myself, I'm old enough to live through the first revolution. And I think right now, this revolution will be faster and much more transformative. So it's really amazing. Today, we will try to kind of make it ChatGPT 101 and combine this session together with information that specifically relates to data center industry, but also some general information about ChatGPT and AI, so guys can come out of this a little bit more educated. We'll try to demystify kind of the black box of ChatGPT, discuss the differences of development on ChatGPT, on AI versus regular web development that we all kind of learned to love. We'll talk about the implication that the AI is going to have on data centers and colocation providers. We'll discuss data integrity, data transparency, data sustainability, and we'll also discuss the lessons that we think the data center providers and data center industry in general should take from the mistakes that were potentially made during the internet revolution, which was arguably won by hyperscalers, which some of you love. Some of you love a little bit less. And perhaps we'll talk about how you guys can become a part of this change and an engine for this change. So with this said, let me start to introduce our panelists today. We'll start with Konstantin Goltsev. Konstantin is a managing partner at The Mind, which is an AI ML consultancy. He's an AI expert, Berkeley math grad with extensive experience in building innovative AI, ML products and platforms. Konstantin, please welcome to the stage. Applaud. We'd also like to invite Vova Soroka, who's also managing partner at The Mind. He spent 15 years in IBM research. He's an author of dozens of research papers, book chapters, as well as 19 patents. He was named the IBM Master Inventor and worked with AI for many, many years. Please welcome to the stage. Here we go. And I was told to start the timer, which I didn't, but it's okay. Here we go. I did it now. Okay. Here we go. So we'll have a few extra moments. So first of all, I'm sure I didn't really give a proper introduction. So I'll give you like a minute and a half to tell us why we really should listen to you, because, I mean, really, why should we? So let's establish that authority right here on the stage. Okay, Konstantin, go ahead.
Check. Yeah, that's
fine.
Yeah, so I've been doing technology for over 20 years, and since Berkeley days has been really interested in neural networks and AI. It all started with linguistics class with a professor, George Lakoff, and we were, mid-90s, we were building neural network models to approximate language, right, and learn language structures like pronouns and whatnot. And then, interestingly enough, the exercise was from these language models, which were neural networks, then get insights into how humans process language. So this is when it all started. And even then, results were uncanny, right? It would learn these primitive multi-layer perceptrons would learn from pictures the pronouns and positioning of the objects, and already kind of correctly
Dangerous
identify
subject pronouns right now.
many. Yes. So, and then kind of following the industry, we also participated in the project to build one of the first trading systems, trading US equity stocks with recurrent neural networks in early 2000s, and then on and on and on. So my career always touched on AI somehow.
Thanks. Vova, the same?
Okay, so I started my career in '95, and I was fortunate enough to be the first programmer in the first Israeli internet service provider. That's why I like to refer to myself as the first Israeli internet programmer, which is obviously a lie, but I like it anyway. Then I joined IBM Research, where I was fortunate to work for 15 years. I started to work on search and collaboration, instant messaging, and it all very quickly became AI and Watson, and now after I left Debater, so AI is also a central part of my career. And for the last 7 years, I made another unfortunate decision to become an entrepreneur, which I'm doing until this day.
Sounds good. Great. So first question will be to Kostya. So it looks like we only have 2 mics, so we'll throw them around. So Kostya, so first of all, let's start from the basics, right? Everyone is speaking ChatGPT. Everyone is talking like they're this big pro and know what it means. But really, most of the people that I met, they just know how to use the prompt in the browser. They have no idea what it really means. Can you demystify for us the black box of ChatGPT or large language model? And many people say AI was around forever, so there's something different right now. So tell us about what is ChatGPT really? Can you just demystify a little bit?
Yeah, so I'll try to the best of my ability, but in essence what ChatGPT does, it just tries to predict the next word based on the context of the conversation. So you can call it, our frontal cortex without all the guardrails of sanity or or really, knowledge about how the world works, right? It's kind of, a master hallucinator. So giving a context, it will produce kind of, the next most obvious word that's supposed to fit that context, and so on and so forth, right? But why is it so amazing? It turned out, quite surprisingly for people about a year ago, right, that these large language models have emergent properties that predicting the next word in context is actually very powerful, right? And some of these predictions are actually more stable in many domains than we thought. So for example, it can do logical reasoning to some degree. It can solve quite simple puzzles. In the beginning, when ChatGPT 3 came out, it was quite unexpected because all we expected was just a stream of this hallucinatory discourse. And really what made it all possible was something called transformer architecture, and that paper came out in 2017, and then people started playing with it, right? And again, the idea was to create academic applications to see how we can model language. And something like ChatGPT GPT-2 model was developed, and already it started showing this ability to produce pretty cogent paragraphs in context. And then the idea was, again, it was just an experiment. Well, let's try to extend it and just, give more oomph to it. Train, bigger system for longer. And that's how ChatGPT 3 came out. And also a lot of its abilities had been actually languishing for about a year in OpenAI with people experimenting with it, but not really uncovering these abilities that later came out with ChatGPT. And what happens, the size of that model, because GPT-3, unlike GPT-2, is several orders of magnitude larger, led to these, hidden abilities. And then the next step was taking this GPT-3 model and then fine-tuning it for human communication, which also kind of was done on a lark. There was a single person, I believe, in OpenAI that really pushed for it, for adoption, because they wanted to create some kind of a product. But again, the result was not predictable. They didn't know that taking this GPT-3 model with its latent abilities, but putting it into a chat mode, making it easier for humans to communicate with it, will unleash this, new capability.
Okay, so is it true though? I read even in research papers, that you guys really have no idea how it really works, right? The exact way it works, the mathematical way.
No, I mean, there is clear understanding of how it works and what it does. The thing is, it's kind of, a self-created structure. So, for example, I take a bunch of colored marbles, I, throw them up, they're gonna fall on the floor in a certain pattern, right? It's clear to me what's happening. I know what the marbles are. I know, that the gravity is gonna pull them down. I can even maybe predict some distribution, how they are gonna fit on the floor. So these processes are known, but then exact configuration of these marbles is exactly what's responsible for how ChatGPT behaves. For example, GPT-3 model, for example, it can do surprising things, like, we all played with it, but it learned how to separate the form of the language from the content of the language, right? So I can tell it, tell me, the manual on how to fix my fridge, but, reframe it like, please tell me like it's a Shakespearean sonnet. And it will do it, or, tell it in haiku form, it will do it. So, it separated content from the language. So the way these marbles have fallen actually allowed, from the massive data set and learning, this happened. We know, that this happened, and we kind of understand how, an analogy with gravity, but the exact, pattern, because the pattern is so complex. So ChatGPT has 175 billion parameters, which are these dials that dials and knobs that you turn to teach the model to do anything. So that's an enormous parameter space. So, it's chaos. We don't know how exactly it does it, but principles we understand really well.
Okay. And as a follow-up, because of all these different parameters, so we know that, for example, OpenAI spent tens of millions, if not more, of dollars of actually training the model. On the opposite side of it, we heard Rebecca Weekly today from Cloudflare. She was amazing on the keynote in the morning, and she said, listen, we could actually train and inference models on like a calculator, right, or something like that. So what infrastructure, what type of resources really does it take to train a model and then to serve the model to the public?
Yeah, I mean, these are two processes that are related but different. So inference is when we take already trained model, and it's just an image, an object in memory, and it could be quite large, but even manageable, maybe spread across several gigabytes of memory. And then we do a forward pass. So this is one calculation where we take an input, and then we do a calculation, recalculating what, let's say this is GPT-3 model, 175 billion parameters. That means we have to do 175 billion calculations of the input to produce a result. So that's an inference run. And this is what GPU does in one pass. Or, if it's on CPU, we run this process, we do this calculation, and it's done. But this is a trained model, right? Like, while we are training the model, what we are doing, on each input, we are constantly adjusting 175 billion parameters, then running the next input and adjusting. So the training of the model might involve, multiple millions of these forward passes. So it's an entirely different beast, right? Like, so if, let's say, we can do an inference of let's say, medium-sized GPT model of, one, let's say, A100 card, to train that model might require hundreds of these cards and weeks of time, and in case of GPT-4, for instance, they were using the Azure farm with, I think, 12,000 to 15,000 N100 GPUs, all, highly interconnected and running months of compute time, and gigawatts of power overall spent. So training is extremely costly, right? Like, you wouldn't be able to train on the edge. And even if you're deploying on the edge, and this calculator is probably a pretty primitive language model, so there's not much that it can do, right? So there are nuances to this, right? Like, you might be able to run something on the edge. It could be cheap, but it's not going to be very useful.
Thank you. Vova, for you, you are first and foremost a software developer, at least originally that's what you were trained of. And as a software developer, what is the difference between a standard web dev project that we all know and love versus AI project as it concerns, for example, infrastructure or DevOps or anything else? Like, what are the differences?
Right. Okay, so as I told you, I'm writing web programs for like 30 years. And well, first amazing thing is that nothing changed. Despite people telling you that we all evolved, that the same things that we are doing for 30 years. And as a result, the web project today is not a big mystery, right? So you have your developers, they come in, they start writing code, and when they deploy it, before they go to production, they can deploy it on a single machine in their garage, and it's probably gonna work. And then when they even go to large production deployments, we all now know how to do it. We have containers now, Kubernetes. Even before that, we knew how to scale it vertically, horizontally, whatnot. What's happening now when we see more and more AI projects that are becoming kind of, well, it's not a commodity, but more and more people come and say, let's do an AI project. So a very simple way to do it is, of course, call OpenAI API and be happy with the result. But you won't be surprised that for many, many startups and many, many companies, it's not really the case. And now those projects have problem number one, we don't have many people who know how to train models and do something with it. But problem number two, which is much more acute, is basically, okay, so now to train models and to do something meaningful, as Konstantin just said, you need machines, you need GPU cards. It's all very expensive, but even though it's very expensive, you just go and hunt for them. You actually go and look for different providers who can give you some, and you fight with other people for the resources. And after you're done doing that, all this process, like all these standard things that we did for web development, like DevOps, comes and configures the system, and everybody knows how to do that. Everybody has templates, and it's so easy and nice. Now, every project I saw and every client I saw, they wing it. They try to see, well, which machine do we have? How do we provision GPU cards? What are we doing? And it's also non-standard that it's almost painful. Right?
Can you give a real example, maybe like a customer example or something?
Right.
Without
so,
naming names?
Yeah, of course. So we work with one of the startups that wants to change the way we buy things online. So basically they want to create a bot that, becomes a sales assistant, but not the old way when it asks you a couple of questions and then says, we'll send your request to our human operator. But an assistant that actually can sell, can close a lot of deals itself. As you can imagine, just putting it to a standard ChatGPT model and hope for the best is not going to work. And the guys need to add a lot of intelligence into this bot. So basically, they start, well, the first requirement they come up with, they say, we don't want to use any commercial model because we are afraid that all our knowledge, proprietary knowledge that we want to put into the system is going to be going to leak into another people's models. Second, so they want to train something specific, and all the problems that I just mentioned, of course, come up. Second of all, it's an interesting story because people who start the startups, they are not technologists, and people have an assumption that if you are not a technologist and you have an idea, it's simple. You just hire someone and they do projects. With AI, it's not the case. So we basically see the whole story unfold working with this client. And everything from development to cost becomes very, very tricky.
Mm-hmm. And as far as I know, even one of those projects, they compared, based on historical data, the performance of a sales agent, a regular sales chat agent, with a ChatGPT sales agent that was trained specifically to sell a certain type of product, and the chat was 30% more effective in selling actual sales. So, just kind of keep it in mind, and this is just the beginning, right? All right, so we started this session, and this is kind of going to be for both of you. Maybe we'll start with Konstantin. We started the session with the phrase that we are right now on the cusp of this new AI revolution, right? And that it's a second revolution that we witnessed after the internet revolution. Do you see any similarities or between these two revolutions, or actually differences? Maybe that's also very important. Like, what do you think?
Yeah, I mean, when already 20-something years ago, right, the internet was coming up, and especially after all these bankruptcies of companies that were built on, the growth of internet promise in 2000, there was a huge debate: will internet succeed or it's a fad, right? Like, and you had all, kind of ranges of opinion that everything is going to go online, or this is going to, just be relegated to the geeks. And, the verdict was at the end, yeah, everything went online, and the impact was rather, underestimated by pretty much everybody, the impact of the internet. It went from wave, after wave of innovation on top of the internet that changed our world profoundly, right? Like when we were sitting there in late 90s, would we think that something like social media would come out and that arguably could rewrite the political history of United States and the world and all of these humongous implications. So if anything, we really underestimated the impact of the internet back then, right?
Well, we say can we also say that the data center industry underestimated?
So yeah, so going back to that, right, what happened later, at least in my understanding, is that, we were all selling servers to software developers, and I was on the side that was buying servers, and then the early cloud appeared, and these guys, who were building early clouds, they didn't have servers, but they wrote software that made operating servers efficient, and lo and behold, right now most of the software development dollars, as far as infrastructure, go to hyperscalers. Why? Because they bothered about the software, and they kind of flowed with the tide that was sweeping everything in front of it. So similarly here, I mean, I sitting on the receiving end of all the clients' requests to build AI, and just already over the years with our group of PhDs in ML following closely the development, I really think that this AI wave is going to rival or be equally as large as the impact of the internet, right? Because the internet put all the data out there for everybody to access in a cogent form, and these AI agents that are emergent are actually going to be able to process this data right now and do useful work, right? Like in my opinion, literally 90% of all knowledge economy is going to be disrupted in some way, shape, or form in the next 5 to 10 years, and how profoundly we still need to see, right? And as far as data centers, the implication is, hyperscalers kind of, ate all the web development dollars away from data center operators because they wrote software. Maybe, this is another chapter where you guys can maybe participate in this next wave by adopting, the lesson, from the last wave, trying to climb that margin ladder, and maybe incorporating some of the software and AI services into your current operations, because that wave is going to be huge.
Ova, do you want to add to this?
Yeah. So some of us that started playing with this emerging thing called the internet in the early 90s. So today, well, we are old, so we look back and we they took our internet. So
Well, you are old. I'm pretty young.
I know. So basically, companies like Meta and Google and others, they were our heroes when they started. Everything's going to be open, everything's going to be great. And now we all feel that they kind of monopolize the space, right? So what I want to mention here, and I think that AI is very similar in that sense, is that now already we see that AI is not democratized enough, right? So we know that OpenAI is a Microsoft baby at the end. And if we just don't do anything, we're going to end up much quicker than with the internet, with a situation where AI is big corporations' baby. Now, my feeling that AI is actually a feature. So this is what's amazing about AI. It's not a platform that we're going to use. It's not ChatGPT. It's going to be something that we see everywhere, from cars to any startup product that goes out there. And to help those people to actually not be at mercy of big corporations, we all need to give them a hand. So that's the opportunity to actually make AI in all its shapes and forms very accessible to people who don't have to pay millions of dollars to even try and develop it in those.
So we get an idea just as again, it's more like a back of the napkin. But for example, how much if I go to a hyperscaler, let's say AWS, and I want to train something, how much does it cost? Maybe, I don't know, Konstantin, Vova, you can each one of you jump in. Not like how much it costs to train the whole model, but in general, like an average project.
I mean, it depends on what your average project is, but let's say you're a corporation, let's say, I don't know, you're a large law firm, right? And you want to build like a semantic search engine for your legal files. Let's say you have, terabytes of these cases going over a long time. So ideally you'd go to AWS and, get a few of their large instances. And these, are rigs that have around eight A100 cards quite a lot of RAM, quite a lot of storage capacities there. But there is sold at, say from $30 to $40 an hour.
An hour.
Yeah,
So you'll take a few of those, right?
Yeah, you take a few of those, and then you run them on the order of few weeks, right, of time, basically fine-tuning some mid-sized GPT model, maybe 64 billion parameters, and that would take a couple of weeks, and extrapolating that maybe 30, 40, $50,000, and that will produce pretty decent result for you to work with. But
And are there many options right now to go? So we only have hyperscalers, or there are like?
No, there are options, but they're just not well structured, right? Like for example, even now, some people are reporting, and we have these difficulties too, just getting GPU compute, decent GPU compute out of AWS is pretty hard. So you start scrambling, you start looking for, maybe on Google, on Azure, and there's not a lot of places where this capacity can be found. So a lot of people think of, going on-prem or using bare metal providers to build out their own systems. And then, it's cheaper, it's faster, and that what. So people go into all kinds of shenanigans to solve this. And this is, I think, where opportunity is where, if you guys just, get some hardware and software in people's hands, make it easy, I think there's a real dent where, you can really start taking some of that business away from hyperscalers. Just because, AI is less, as Vova said, AI is much less uniform than standard web development. Because of this idiosyncrasies, right, it's much harder for hyperscalers to compete at scale. So I think there's a bunch of dollars that would be left on the table by them in the near future, where you guys can kind of, make your opportunity.
Okay. As a segue from this, it's a good segue, and we can start with Vova on this one. But I want to address kind of the three elephants in the room that are mentioned a lot on the stage of this conference as well, specifically by Bill, not once, not twice, but more than twice and three times. And these are, as Bill likes to say, AI integrity, AI transparency, AI sustainability. And I think that data center providers can really capitalize on the need for all three, right? So let's start with the first two. I think they're more related. So we saw a lot of concerns around the fact that maybe Vova can start with this. Vova mentioned that OpenAI stopped being open source, closed everything. There were complaints about OpenAI ChatGPT being biased, right? So with this context, what are your thoughts about this, and how do you think data center industry can help ensure that AI integrity and transparency remains there for us?
Right. Yeah. So I already mentioned that basically, what's democratization of AI? It's basically making everyone, like everybody, be able to train their own models, right? Because it's as Konstantin said, it's a hallucination engine. That's half of the problem. The other half of the problem, if you don't know on which drugs it hallucinates, it's really unpredictable, right? So people need to be able to train their own models. So it needs to be open, it needs to be transparent to the world, and so on and so forth. And for that, we need infrastructure. And if the only way to get this infrastructure is from very large companies that has their own AI agenda, then you can imagine it will be very difficult to do that at cost and so on, right? So I think that data centers here have a huge potential role for people to become this place where they can come and host those models and train those models and share those models with the world. And it could be a great opportunity.
Konstantin?
Yeah, I mean, and again, because of amount of value that's going to be unleashed is just titanic. So this is comparable to the effect of the internet, I think, several times over. So what turned out lately to be true in the last 6 months or so is that you don't necessarily need a large language model on the industrial scale like ChatGPT or GPT-4 to do a lot of useful stuff, right? You can take smaller academic models or open source models on the order of, let's say, 6 billion parameters, 30 billion parameters, and then you can fine-tune them with exactly the same methods that were used to create ChatGPT, and the results are very decent. On a lot of applications, these models perform as well as ChatGPT or outperform them, which was an amazing result. So that means for democratization that, even small to medium-sized businesses can really create their ChatGPT competitors, fine-tune them on their domain, and extract a lot of value out of it. And transparency here is important because, for example, if I am using this GPT model to run my business processes or, let's say, interface with customers, I really need to know, as Vova said, what it hallucinates about, right? Like the model really need to be tightly rated in terms of the data that it learned on. So there are no surprises, or limit surprises as much as we can. And also, that goes for so-called system prompts, right? How is the model conditioned to respond? So, for example, a lot of people complain that ChatGPT is a little bit woke. I mean, so on some on some levels, if you ask it for a joke, it will produce a joke about men, but not about women, and stuff like that. So the nuance of this is that if you're really building these GPT models to actively play active role in your business, as I'm sure 90% of the businesses would, they would need to be able to know what data the model trained on and what are the parameters of that model, like these system prompts that condition it, right? And this is where transparency and democratization is important.
You mentioned to me once that when the latest ChatGPT 4, I think, came out, that you and your team read the actual paper, white paper that came out with it, and you guys didn't find really anything about.
Yeah,
anything
I mean, OpenAI did a little stunt where they were actually, a non-profit, where even somebody like Elon Musk donated $100 million, and they did a little legal stunt where they actually took all the IP from the nonprofit and they put it into a for-profit company, and then Microsoft financed it. So they really hijacked whole agenda. And yeah, of course, their GPT-4, like there was a lot of information, technical information, and they were pretty transparent on GPT-2 and GPT-3. And already with GPT-4, the whole 158-page paper is basically a marketing brochure with zero information about how the model was trained, how the model was created. So that goes to show it, right? Like that.
This is just the
Yeah,
first,
the
right?
big-
So
the
now
big-
we're going to
yeah.
have everybody else come in, right?
Yeah, the big corp probably has an idea where they're going to train huge foundational models, and everybody is going to go to them to basically use them. They're going to monopolize. It's kind of like they did with the cloud infrastructure, which is kind of not the case, right? Like it became apparent in the last 6 months that in fact, yes, you can train your own smaller models, and they're just as effective for a lot of tasks as others.
Okay.
I mean, as the big ones.
Now let's talk a little bit. You can start. Let's talk a little bit about sustainability, right? So beyond the good that sustainability brings, right? The saving of the earth and the energy, etc. It also, from what we learned, right? There's a certain capacity that ChatGPT and AI models basically demand, and sometimes they don't even exist, right? So how does sustainability, kind of is relevant within the AI and ChatGPT models?
Yeah, I mean, it's important. For example, ChatGPT-4 was trained on this supercomputer cluster from Azure. I think 12 to 15,000 A100 cards. Each card is sipping around 300 watts, right? Like I think so. The whole system would, I think, sip around 3 kilowatts per hour. That's just one server, and they're like maybe.
Math Berkeley, I mean, that's where he gets this
2,000-3,000 of them.
Like
so this enormous amount of electricity that was consumed and burned. And nobody's going to stop there, because the truth about these models is you can either take a very large model, let's say like ChatGPT-4, GPT-4, maybe it's 500 million to 1 trillion parameter model, and you can train it for a limited amount of time and it will produce good results. Or you can take a smaller model, but you have to train it, way longer, which still, so whichever way you slice it, you need a lot of power and you need a lot of capacity to produce these foundational models. And the world is not stopping. Like Elon Musk is ordering 10,000 GPUs for, his Project X for Twitter, stability. Like everybody.
What do we do?
Everybody is competing. And then by implication, if we can find pools of resource, for power, for instance, that are green, let's say, it's geothermal or renewable or solar powered, then a lot of burden on the environment would be diminished. And then, another strategy you could do, you could really look at specific business applications that you're looking for. And then the question is, well, do you really need these humongous models that you need to train? Or you can get away with something smaller, with less of impact. You can also use software engineering techniques like stopping the model early, not going that last 1% in model precision, so that, you get essentially the same result, but spend, half as much electricity on this and others. So all of these tactics are important to diminish the impact. Also, important part of it is using second life hardware. So all of these components that are being decommissioned by hyperscalers, you can actually, create very decent systems out of them. And with proper engineering and proper tuning of your business case, you probably can get very decent results at a fraction of the cost and at a fraction of the power.
Okay. Before we open to questions in the audience, which I hope there will be at least a few. Otherwise, I had ChatGPT write some more questions, so if anything, we can turn to them. But this last question is a little bit borderline silly, and I want to hear both of your opinions, but it's really not, right? So, if would any of the people present in this room right now, right, can be potentially responsible for hosting the next Skynet? Can AI take over the world? It looks like some folks, including Elon Musk, and think that they could. So, what are your real thoughts about this? And both of you, please, maybe start with Vova.
Well, a friend sent me a picture. Well, the easiest way to stop the Terminator was just to show him CAPTCHA. I'm not a robot. But seriously, okay, so as we tried to explain, GPT models are not really intelligent in a sense that they don't make decisions, at least not intentionally, right? So we're a little bit far from apocalypse if you just let ChatGPT run and train. It will all really depend on where we connect this stuff to, right? So if you connect it to all sorts of red buttons, maybe it will be really dangerous. And I think also a lot of research needs to be put into realizing more and more how those models work and how they make their inferences, because there are some unnerving results coming from people's interactions with ChatGPT. But still, I think that technology itself is going to be tremendously helpful. And unless we are not really careless, it's not going to destroy us, really.
Konstantin?
Yeah, I mean, there are tons of voices on that. And as usual, with all of these phenomena, there is certain very vocal spectrum of people, minority who think it's doomsday, right? And it's been, probably across all of the issues, And similarly here, I mean, there are a number of people who think it's very dangerous and they're very vocal, but there is, a huge community of people who think otherwise or are not that worried. So there are scenarios which, taken to extreme, can indeed, hypothetically lead to adverse outcomes, and specifically what people are worried is something we call AGI, artificial general intelligence. So this is something, fully embodied system which is smarter than the smartest human by, some insane order of magnitude, kind of, like this artificially intelligent God. But we're very far away from these systems, right? It would take
a few months,
maybe, a few weeks. No, but we see the germ of these systems already in current GPT models with something called, chain of thought, where you produce an output from the GPT, and that output that feeds is recursively fed into the next, GPT Q&A session, and all kinds of interesting outcomes can evolve from this, right? You can ask the model to write the business plan, outline the bullet list, and then on each bullet iterate, implementation, and you can get very into nitty-gritty, right? But usually to make these things robust and functional, you really need to evolve them in an environment for a very long time. And, general environment, like the world is very complex. There's not a lot of opportunity for these, systems to evolve and explore the parameter space so they become robust. So it's going to take us a while to to really get to something dangerous because of this, right? Because even right now, people play with these baby AGIs and chain of thought models. Very quickly, people will see that these things run into dead ends and behave like lemmings. So it's not easy, but it's going to be done eventually, right? Like, but that eventuality is completely unclear. We've certainly got one element of it is the model that, in some fundamental way, has cracked the language, right? An ability to produce a language in context. And now all the other components are equally difficult, and researchers are not quite clear what they are even in many cases to produce the AGI, artificial general intelligence, right? But then the fear is that once you produce the first version of it and you give it a simple task of, well, produce a more advanced version of yourself, and it will do it, and then, so forth, a certain iteration is going to have this godlike powers that will decide our fate instead of us, and that's the fear of billionaires. I'm not worried.
Well, there you have it, folks. We're safe for a few more weeks, so that's good. It's good news. You have time to go home and say that you love everybody. Anyway, but what I think, if we take anything away from this session today, and I will open it right now to questions, but first of all, we know that this revolution is happening, and I think that all of you need to take away from this conference that whatever business you're in, whether you're on the edge, whether you're colo provider or bare metal provider, or you're providing technology, doesn't matter. You need to capitalize on this wave. You need to ride this wave because you are basically the infrastructure of the future of humanity. And if before that it was the infrastructure of the internet and it was evolving very slowly, right now this is changing our lives in a speed that, we're laughing here about weeks, but it is true. Konstantin gave me a book as a present about ChatGPT, and it was published 3 months ago. It's completely outdated. There's a few chapters still make sense. Everything else is outdated. So you are the infrastructure of the future of humanity. You need to understand how you ride that wave and probably not do the same mistakes that some of us did 20 years ago, where we limited ourselves to something, saying, listen, I'm only in real estate. I'm only selling servers. I'm only selling energy. I think there is a way right now for all of us to capitalize on this wave and actually, with this capitalization, democratize AI for everybody and make it more transparent for everybody and make it more sustainable for everybody. So applaud to our guests here. Let's open it to questions. We have, we have 7 minutes and we have 11 here. I can believe either timer there, but here we go. There's a guy. Here we go. This is Jason right here.
All right, so question. We've heard a lot of people talking about ChatGPT and saying, oh, it's a toy, it's cute. Look at what it can do. This is kind of fun. It can let my kid cheat on his homework. Have you, I've got a couple of ideas, but have you seen any killer app for this type of large language model?
Thank you.
Yeah, the obvious killer app that we're actually implementing for a few clients is semantic search. Where, you chat with a huge PDF doc, which might be 1,000 pages of specs, and you need an exact answer for your question. How typically we would do it. We'd, get a bunch of keywords and start clicking, going over keywords, trying to understand. And really nobody solved semantic search until now, and GPT models are exactly that. You give them a word, and there is this multidimensional space of vectors which represent specific ideas. There are points, in that vector space, and GPT model actually maps out your exact idea into the idea space. And then from that idea space, it can, produce an answer. So that's an impressive application that's immediate, right? Yeah.
And it's also basically every industry can use it,
Another one is, generation, like data translation. So you can, literally, have it map, from, not even like JSON formats and whatnot, XML, different languages, because it's been trained on GitHub on corpus of software. So especially these fine-tuned models are very powerful. You can give it a Python script and say, hey, rewrite it in, Perl or whatnot. Yeah. So content generation, and you can go on and on and on. I think that's why I think that 90% of knowledge economy will be disrupted. And by the way, the most dangerous thing here is some of these applications, the power is that we are not aware of yet, right? Because what happened with GPT-3, it was really sitting there for a year, and people were just academically experimenting with it, and a lot of emerging capacities were not apparent because you really have to. It's like an alien artifact. You sit there, but you have to query it and do experiments and understand what it can do.
Thank you. Any more questions? Yep, I can see one in the audience there.
Yeah, it's excellent questions, and the news is very good. So, for instance, we have a client. We took, and we just completed this experiment last week. We took a larger GPT model, 64 billion parameters. For instance, this is the level of the models that Bloomberg just trained on their financial data, and we put it on a Second Life machine from Cato, which I think has 256 gigs of RAM, and we put it all in RAM. I mean, obviously, we rewrote it in C++. We did a bunch of modifications. We put it in, and with various quantization techniques, and quantization technique is where you basically, make the model, instead of computing in, 32-bit words, into 8-bit words or 4-bit words, 4-bit vectors. It makes the model take less memory and makes it faster. But we got some very decent results. I mean, that CPU would generate, I think our best was about 3 tokens per second. So it's like 2 words per second it would generate. So amazing part is that, it's not like real time. It's not convenient to chat with. But in an offline batch capability, if you, sit it there and, tell it to analyze the doc, produce something and whatnot, perfectly feasible. And it's a large model, it's 64 gigs, right? And that can do a lot of work, and that server is maybe $200 per month, maybe less. So apparently you don't need like the latest rig with a bunch of A100 cars to do these things if you do proper software engineering on them, and that people are experimenting all the time. So very good news for Second Life hardware. With a little bit of engineering, all of that, that's even 5-year-old hardware is very relevant.
Any more questions?
Just inference, but we have to modify. So we modified, some code, basically to make it faster, some optimizations and quantization, and then we did experiments on various quantization levels and how fast the inference for token takes, and it's very decent results.
Maybe one last question. Here we go. You have 2, okay. All right.
So to the first, yeah, I mean, that's our bread and butter. We are an AI consulting practice, so our guys, monitor all the latest papers. And for instance, it's not just bright.
Okay.
It's not Hyena, but we have, what we did recently for a client is semantic search, but on a smaller fine-tuned model, around 250 million parameters, it has unlimited context. I mean, not unlimited, but several, it can take from hundreds of thousands to millions of tokens in its context, to do the semantic search and analyze everything. So I think these papers are coming out every week. People are tweaking their architectures. People are really trying to get to the bottom of abilities of these models. And yeah, the latest is, a lot of smaller models perform just as fine. And then, of course, there are kind of different ideas about the whole architecture. Like the transformer itself, it looks, only backwards to produce the next token, and then people did actually analysis on how human mind works. We not only look at the context which is prior to the inference, but we also project, some of that context forward, and then from that prediction, we formulate the next sentence and whatnot. So tons of ideas, and I didn't quite follow about the open source.
Which open source models you use when you produce?
You can go, if you want, later I'll give you links. There's a whole menagerie of models. You know, they're groups.
Example.
I mean, it slips my mind, but there are like really 100 different models of various sorts and guises that people have already developed, and you know, Stanford has this wonderful description of that menagerie, and it is growing.
Thank you. Sure.
Sure. I mean, as long as you can make software work, and I mean, AMD has their own version of CUDA. It's just going to take you a bit more tinkering, but in the end, the tinkering I don't think is too expensive. So if AMD has decent, or Intel has decent GPU hardware, by all means. Again, like the idea being is, one of the issues is I feel like the whole data center industry underinvested in software tools during the internet boom, right? And thus, you know, a lot of business, most of it went to hyperscalers who, in fact, invested and built that software. So the idea is, look, maybe there is some kind of pooling of resources and investing into software framework for AI that it democratizes and it doesn't go to another hyperscaler, you know, of tomorrow. So there's more dollars to spread around.
Thank you, Konstantin. Thank you, everybody, for coming. I hope you enjoyed the session.